Good afternoon to all. Today I will discuss about solid state welding process under unit 3, and end of this lecture student will able to learn about laser beam welding, electron beam welding, resistance welding and its different types. I will discuss about that welding process in this lecture. Electron beam welding. First, introduction about electron beam welding. Actually, that is a fusion welding process. Fusion welding process means here we apply the heat, and due to heating to the particular workpiece, the metal will convert it into molten metal. Molten means plastic state condition, it will be converted. Then the workpiece will be joint. Means in this particular electron beam welding process, we use a beam of high velocity electrons. Means a high velocity of electrons we have applied on that particular workpiece, and that will help to melt the workpieces across the welding joint face. Okay, and apply two materials to be joint, and that free electrons in vacuum can be accelerated. Here why we are taking the vacuum condition in case of electron beam welding? If that beam of high velocity electrons collide with the air particles, the velocity of that particular high velocity electrons that will be reduced. Means velocity of electrons that will be reduced, and due to reduction of the velocity, that will not come properly to the workpiece, and due to that thing, the melting temperature of that welding phase of that work material that will be reduced. That is not good for that welding process. And path control by the electric and magnetic fields, and the flow of electron beams that will be controlled by the electric and magnetic fields. Some devices we have engaged in that process that will help to control the flow of the beam of high velocity electrons. And that beams, that is the narrow beams of electrons carrying out kinetic energy can be formed. Means the flow of electron beams that will be converted into kinetic energy. Okay, means collision with atoms in solid transform their kinetic energy into heat. Means continuously flow of the electron beams to the workpiece that will continuously striking on the workpiece, and then after certain times the workpiece will be heated, and due to continuous striking of the electron beams on the workpiece, that workpiece will be heated, and due to heating it will be converted into molten zone or plastic state condition. Generally, electron beams composed of electrons. The particle having rest mass of near about 9.1 10 to the power minus 31 kg. Okay, and that can be accelerated in electrons using electron guns. The flow of the electrons that will be accelerated. Okay, and take the particular velocity that will be converted into high kinetic energy. Near about 10 kilovolt which generated 13 horsepower power. In that cases, electron travel approximately 20% of the speed of the light. Means that particular 10 kilovolt electron take approximately 20% of the speed of the light. Means it will take high velocity. Means 20% of the light means it will take the more and more velocity. While 200 kilovolt near about power 270 horsepower, in that cases electron beam travel near about 70% of the speed of the light. Means the flow of the electron beams taking very high velocity, that will be converted into high kinetic energy. Electron beam welding, in that cases we are seeing that will be emitted from the, actually electron beams emitted from the heated filament called electrode. Means that electron beam are heated from the heated filament. Heated filament is connected to the electron beam welding setup, and due to higher heating of the heating element from that electrode, electron beams will be emerged out, and that full process will be carried out in vacuum position. And these electrons generally applying high potential difference, means very high velocity of electron beam is required, means beam of high velocity of the electrons it is needed. Due to that thing we apply the very high potential difference, that will be ranging from 30 kilovolt to 175 kilovolt, and in that ranges the electron beam velocity will be very high, and that voltage will be applied between cathode and anode of that particular electron beam welding setup. And higher the potential difference, higher would be the acceleration of the electrons. Means already I have discussed the higher velocity, the velocity of the electron beams near about 70% of the light. Means it will take very high velocity, and that high velocity helps to strike on the workpiece material continuously, and heated also that workpiece materials also. Means the electron gets speed in the range of 50,000 to 2 lakh kilometer per second, means very very high velocity taking that beam of electron beams. When high kinetic energy beam strikes on the workpiece, high heat, means when hitting on that workpiece to high kinetic electron beams, very high heat will be generated in that particular zone. Very high heat will be generated. That high heat helps to melting that workpiece, melting the workpiece. If we are want to join across these faces, that faces will be melted due to high heat energy. Okay. After melting, then the gap between two plates, that will be filled up by the molten metal, and after that it will be joined. What are the setup equipments of that in case of electron beam welding? First one, electron gun. Okay, means from that electron gun high velocity of the electron beam also generated. Okay, power supply unit. Second, third vacuum chamber, and fourth is workpiece handling device. Now in that picture we are seeing that here, that is the cathode. That part is the cathode part. Okay, and that part is the control electrode. That part shows the control electrode. Okay, that is the cathode. And here high velocity supply is there. High velocity supply means that is the beam generation unit. Okay, and that part is the anode part. Means in anode and cathode we have connected the power supply. Okay, and when we connected that power supply anode and cathode, very high voltage applied between cathode and anode. Due to higher voltage, the filament will be heated, and due to heating of the filament means that will be present to that electron, that is also called electron gun also. Okay, and due to that thing, very high velocity of the electron beam will be generated. Very high velocity of the electron beam will be generated and striking on that workpiece, striking on that particular workpiece. Okay, and here we are seeing that is the adjustment coil. That is the beam generation unit. Up to that part, that is the beam generation unit. Okay, then beam focusing, and that is the beam focusing unit. And in that beam focusing unit, number of components are there. One is adjustment coil, then stick matter, focusing coil and deflection coil. That components helps to control the flow of the electron beams that will be generated from the electron gun. Okay, means from the heating filament. Okay, all that deflection coil helps to control the flow of the electron beam and also helps all the equipment helps to flow the electron beams and properly striking on the workpiece. Here two vacuum pump is there, two vacuum pump that helps to taking outside of the air particles, means it just emerge out the air particles from that vacuum chamber. Okay, and here we are seeing that is the viewing optics, that is the viewing optics. Through that optics we are seeing the flow of the electron beams. Okay, and that are the valve position is there. Okay, now that are the all the parts, that is the deflection coils and that is the focusing coil and that is the stick matter, and here two vacuum pump and that are the adjustment coil. All the components help to control the flow of the electron beams. After coming here, that is the workpiece, that is the workpiece holding device, that is the workpiece holding device, that is the workpiece holding device. Here we hold the workpiece properly, and in that workpiece electron beam gun directly striking on that workpiece. Okay, and two vacuum pump is there. In that position we also taking the air particles outside. Otherwise, if that electron beams striking on the air particles, the flow of the electron beams, means velocity of the electron beam, it will be reduces. So, and that is the workpiece handling device. Okay, that is the working chamber and that is the beam forming and guidance chamber. 3 unit particularly in that particular setup we are seeing that, and that is the chamber door, and that is the 3D view of the electron beam setup. That is the 3D view, and in that view we are seeing that is the total electron beam generation unit, that is the, up to that part, that is the beam generation unit, and that after that we are seeing the guidance, means beam forming and guidance unit, and that is the workpiece chamber. Okay, electron gun. What is the function of the electron gun? Generally electron gun helps to, actually that electron gun are formed by the triode style, by a triode style electron gun under high vacuum conditions. Always we maintain the vacuum conditions, means here no air particles is there. So first one we seeing that in that filament unit, particular filament, that is the filament unit, that for particular filament unit we have applied one power supply. Okay, then another we are seeing that high voltage power supply also we have connected to the filament, and that is the anode part, that is the anode part. Also anode and filament, another high voltage power supply also connected, and also in that particular filament to end also connected filament power supply, and another we also applied the bias voltage power supply, means triode style power supply we have connected to the electron gun to get the high velocity electron beam. That's why we have connected a triode style electron gun. And another, that is the bias cup, that is the bias cup. Okay, means it is also called cathode grip cup. In that cathode grip cup we have connected another bias voltage power supply. That cathode means that part will be connected to the negative end of the power supply, means that is the negative end of the power supply. Another end will be connected to the filament, means that is the electron source, means that is the anode part, that is the anode part, means in that filament we have connected the positive end of the bias voltage power supply, means that is the triode style electron gun electron beam generator, means it will help to produce the high velocity electron beam. That triode assembly, we have seen that a heated source emitter means here filament is given, okay, and that also helps to maintain at some high negative potential. Also that here we have seen that in triode style electron gun generator, in that cases just one heat source emitter means here one filament means that filament will be heated by the provided power supply properly, okay. Due to higher heating, then filament means electron source helps to generate the high electron beam. A grid cup generally shaped electrode that can be negatively biased means grid cup that will be cathode part and that will be fully negative biased with respect to hot cathode emitter means with respect to filament, okay. Means in that grid cup we have seen that will be grid cup means that is the cathode part, and that cathode part we are seeing that will be connected to the negative end of the power supply, and other end means positive end would be connected to the filament, okay. Means that is the electron source generator. Another, an anode, a ground potential electrode through which the electron flow passes. In that means one another anode part means that is the anode part. That part is the anode part. Another power supply also connected to the anode and another power supply will be connected to the negative end, and that anode part helps to flow of the electrons properly. Means that anode part helps to flow of the electrons properly. The hot cathode emitter generally is made of high emission materials means that is generally we use the tantalum. That material is used for producing the emitter. Emitter means filament materials, and that also heated properly, very high heating element when we applying the higher voltage to that particular filament material, and also available in wire, ribbon and sheet form. That filament element generally available in wire type, ribbon type and sheet form. And generally that emitter material is fabricated being either directly or indirectly heated to the required emitting temperature means we providing the particular emitting temperature means when it will come to the proper temperature that will helps to generate the high velocity electron beam, otherwise it will not generate the high velocity electron beam, okay. Near about temperature due to providing voltage, generally the required temperature near about 2500 degrees centigrade, otherwise it will not produce the high velocity of the electron beam. Other materials such as lanthanum, hexaborite means LaB6 materials also used as a filament material. Tantalum, tungsten, that is also used. Tantalum and tungsten that materials also used for making the filament material. Also another material LaB6 also we have used. Generally two types of electron guns. One is self accelerated means here when we applying the potential difference between the cathode and anode, the electrons are accelerated. Means self accelerated means when we connected the power supply between cathode and anode, in that cases electrons are accelerated. That is the self accelerated, okay. Then another is work accelerated means when potential is applied, potential difference when we applied between workpiece in anode, in that means that is the diode type, that is for that cases that is the work accelerated means here power supply will be connected to the anode and workpiece means particular anode part is there, that is the particular anode part means when power supply will be connected to the anode part and workpiece part, in that cases the flow of the electron beams is work accelerated. Now some example we are taken when we applied the tungsten material, means that is the filament material. Now melting temperature is near about 3422 melting temperature, very higher melting temperature. So in that cases cost per kg $25. In case of tantalum, the melting temperature 3020 degree centigrade. So cost per kg near about 180 to 190 per dollar. So for heating of that particular material, so taking many times, because melting temperature is very high of that particular cases. LaB6 melting temperature 2210 degree centigrade and cost near about US dollar 6 to 12, means in that cases cost is very low respect to other materials. Emitter and filament means that will help to generate the high amount of or higher velocity of electron beams. Anode generally near the cathode, actually that positively charged anode that will kept to the cathode across which high voltage is applied to accelerate the electrons. Means one power supply will be connected to the anode and cathode. Okay, means anode and another filament material. So at that time when electron beam will be generated, that anode helps to flow the electron beams very high acceleration. Okay, for higher voltage potential difference near about we applied 70 to 150 kilovolt. Okay, and low voltage equipment potential difference near about 15 to 30 kilovolt. Means for higher velocity, for higher velocity of the electron beam, we apply the very higher potential difference near about 70 to 150 kilovolt. And in case of low voltage application, in that cases we maintain the voltage potential difference near about 15 to 30 kilovolt. Grid curve, that is the negative voltage with respect to cathode applied. Grid curve controls the beam. Means here grid curve also controls the flow of the beam also. Now focusing of the electron beam. What is the function? Means here some equipments, means toroidal focusing coil, deflection coil, means that type of coil helps to control the flow of the electron beam. Okay, means that controls the flow of the electron beam, means main objective of that coils to control the flow of the beam, and it will strike to the proper welding joint of that particular materials. Means two parts, electron focusing lens, another is deflection coil. Electron focusing lens focuses the beam into work area. Means focusing lens of that particular electron beam setup, that will help to focus the electron beam to the particular workpiece area, means to the weld face of the workpiece. The focusing of the electrons can be carried out by the deflection of the beams. Means that deflection coil helps to focus the electron beam properly to the particular workpiece. Means that is the function of the focusing coils. Means deflection of the coils, that is the main function. Power supply units. Generally we have used the high power DC power source that will be used in case of gun. Okay, and also that power supply also connected to that focusing and deflection coil also. Means that power supply helps to generate the high velocity of the electron beams to that particular electron beam setup. And potential difference high voltage 70 to 150 kilovolt we have applied. In case of low voltage equipment, we have used the 50 to 30 kilovolt. And current level varies from 50 to 1000 milliampere. Not ampere, means current will be 50 to 1000 milliampere. That will be amount of current, that will be depends upon the diameter of the diameter and type of the filament. Means currents, flow of the current, that will be depends upon the diameter and shape or type of the filament. Here AC or DC current we have applied to heat the filament material, and using that filament material helps to generate the high energy of electron beam. Generally we prefer the DC current, its affect the direction of the beam. Generally most preferable current is DC type current than AC type current. Vacuum chamber. Why we use the vacuum chamber? Generally electron beam welding performed in vacuum chamber. Generally the gun portion of the electron beam assembly generally isolated from the welding chamber. Okay, and through the use of valves with laser by using the vacuum dividers. Because why we use the vacuum chamber? Generally the generation of the electron beam flow through the vacuum chamber. If the air particles remaining to that vacuum chamber, the electron beams collide with the air particles, and due to collision of the electron beam to the air particles, the velocity of that electron beam will be reduces, and due to reduction of the electron beams, that will not properly strike to the workpiece and taking time for heating to the workpiece materials also. Means it will time consuming for welding. Okay, that's why if we emerge out the air particles from the vacuum chamber, so there is no particles, means no striking with the electron beam. So always we use the vacuum chamber in case of electron beam welding setup. Vacuum chamber also needed to maintain gun component cleanliness and also prevent filament oxidation. Means if we emerge out the air particles from that vacuum chamber, it does not react with filament chamber. If oxygen particles is kept in the vacuum chamber, that will react with the filament components, and due to reaction maybe any oxide will be formed, and due to oxide formation it will convert it into rusting cases. So impede high pressure short circuit between the cathode and anode and the filament, the grid cup. So always we maintain that component in vacuum position. Most of the electron beam welding we have done generally vacuum environment, where the maximum ambient pressure we applied near about 0.13 Pascal. Okay, and maintenance of that vacuum chamber, that will be very important, because the effect of ambient pressure has on beam and oil produced. That ambient pressure has on both beam and oil produced, means that will help to generation of the electron beam. And that based on vacuum intensity, electron beam welding has three types. One is non-vacuum electron beam welding, means atmospheric pressure. Another is medium vacuum electron beam welding. In that cases we maintain 133 to 3.3 10 to the power 6 megapascal. Another is high vacuum electron beam welding. In that cases we maintain the pressure near about 0.13 to 133 megapascal. Workpiece handling device, means during welding time the holding of the workpiece is very important. Means we hold the workpiece properly, and after holding the workpiece properly we do the electron beam welding process. Means after holding the workpiece properly, then we create the electron beam, and it will strike the electron beam strike on the workpiece properly. After striking, the electron beam helps to melt the weld surface material, means weld face material. Then it will fill up the gap, and then it will be joint. Means movement of the workpiece are easily adaptable to computer numerical control. Means some automatic controlling devices is there that will help to control of the, means flow of the control on the workpiece. Means workpiece movement will be controlled by the using some computer numerical control devices. What are the applications? Generally we have used that in case of joining of the refractory materials like columbium, tungsten, ceramics, another high precision welding in case of electronics components, another high pressure welding in case of nuclear fuel elements, another is special component in case of jet engines, another pressure vessels for rocket, dissimilar metals, joining of dissimilar metals, welding of titanium, medical implants. So very important sector, very huge sector, very heavy industry and very precision industry. We have used that very advanced electron beam welding process. What are the advantages? Means high penetration depth also we have got, high welding speed also obtained in that welding process. Another, quality of the welding is very good, and that welding is a corrosive free welding. Distortion is very less due to less heat affected zone. Inaccessible joints can be made using that welding process easily. Another, very wide range of sheet thickness, near about 0.025 millimeter to 100 millimeter, we can do the welding using that welding process. What are the disadvantages? Very high equipment cost. Equipment cost of that electron beam welding setup is very high. Transportation of that equipment is not easy, because that equipment is a very costly equipment. So transportation of that equipment is also very difficult. Vacuum is required. That is also important part of that welding process. Skilled person, means for handling that electron beam welding process, very skilled person is required. X-ray generated during welding, so we taken care of about that thing also. 60 kilowatt to 4 kilowatt, 4 kilovolt to 60 kilovolt and 4 kilowatt electron beam welder, including CNC control work manipulation system is there. Means for that system cost near about 2,20,000 pound is required. Means for that particular electron beam welding setup, that is very costly, very costly. So in that cases, very high equipment cost in case of electron beam welding, but in that welding cases, the weld quality is very good, and that welding setup also used for very precision welding in precision industry, near nuclear industry and also electronics industry, some automobile industry, some aerospace industry. We have used that type of electron beam welding process. Now I am seeing one video about electron beam welding. That is the electron beam welding setup. Here electron beam welding setup, we are seeing that cathode anode is there, electron beam, that is the electron beam, and that is the focusing coil, and that is the deflection coil. Focusing coil helps to focus the electron beam on the particular workpiece, and air is evacuated from the chamber. Means we are taking vacuum positions, means we are removing the air particles from the particular evacuated chamber. That is the setup of the electron beam welding. That part is the cathode and that part is the bias, and that side shows the anode. That is the generated electron beam. That is the focusing lens. That lens helps to focusing the electron beam to that particular workpiece, and that is the deflection coil. Using that deflection coil, we deflect the electron beam as per our requirement, and electron beam is coming and across the weld face, and that portion will be melted, and due to melting, the molten metal will be filled across that weld faces. It will generate the keyhole. That is the electron beam, and that is the molten metal. That is the molten metal, and that is the welding section. Now using electron beam, we are doing the welding. some cylindrical portion also welded using the electron beam welding, that is the electron beam is coming and so do the welding.